Hi everyone, welcome back. Guys, I have a question for you. Whenever your system got stuck, what you will do? Generally, we are all will restart the system. That's a simple solution, right? Similarly, what about the operating system developers will do? That is our question. When a deadlock happens, right? Means if deadlock happens, what the operating system developers will do? Right, so that I can able to define as in the form of various strategies of deadlock. One kind of strategy is system never going into deadlock. Never going into deadlock. This is one kind of strategy they can follow. Another strategy is system will enter into deadlock. Means deadlock will occur it. Right? So this is a kind of category 1 and this is a kind of category 2. Means the strategies of the deadlock are classified into two categories. Category 1 where system will definitely not going to enter into deadlock. Means they are going to make it avoid or they are going to make it preventing the system entering into deadlock. That is category 1. In category 2, once the deadlock occurs, what they will do, that will be classified in the category 2. Basically, what we are doing, when a deadlock is going to occur in our systems, we are going to simply perform ignoring it. That is what we call it as one solution is deadlock ignorance. And another kind of thing is once a deadlock occurs, means once we detected the deadlock, we are going to detecting it, and from that we are going to recover it. That method we call it as deadlock detection and recovery. In another category, we are going to go with the two approaches. One is deadlock prevention, another one is deadlock avoidance. Guys, here you might think that these two having the same meaning, deadlock prevention and deadlock avoidance. So if I say deadlock prevention, we are preventing to enter into deadlock. Deadlock avoidance, we are trying to avoid to enter into the deadlock again. Both are, you might think that both are having the same meaning, but in general they are going to be differentiated in some manner. In deadlock prevention, we are generally preventing to occur into the deadlock state, right? Which means that there are two friends are there, they are ready to fight. How they can prevent the fighting? By making certain kind of conditions each other. By making certain kind of conditions each other, they can able to simply prevent the deadlock, right? For example, if I say I will give chocolate for you, I will give chocolate for you, tell by person B, and person A will tell, okay, I will give pen for you. That's it. They might get certain kind of agreement so that the fighting won't happen. Prevention means it won't happen. It won't happen, right? Means which is going to follow certain kind of conditions to eradicate the deadlocks. Follow certain conditions in order to avoid the deadlocks, right? So in order to avoid deadlock, it can follow certain kind of conditions. What are those conditions? Just think about what are the characteristics of deadlock that we have seen in the earlier classes, like we can see in the terms of necessary conditions, right? If I am going to disable, guys, just think about it. If I am going to disable all the necessary conditions, can I prevent those or not? Yes, we can prevent those, right? Simply, whatever the process that are executing in our system, those has to compulsory follow mutual exclusion. This has to follow compulsory mutual exclusion, which means that we should not allow resources to use at same time, then definitely mutual exclusion is guaranteed, so that there is a possibility of avoiding the deadlock, right? Which I can say it as a spool everything. This is the property that you have to follow. And the another kind of condition what we discussed is hold and wait, right? So if you are going to avoid the hold and wait, there is definitely we can avoid the deadlocks, right? How we are going to avoid this hold and wait? For example, process PA is executing by having a resource Ri, right? And it is waiting for another resource Rj, which means this is hold and this is waiting, right? So this waiting process has done at the runtime, right? So here deadlock is occurring because this Rj is using by somebody like P2. So that's the reason we are going to get deadlock, right? So to avoid this, what we can do now? We can simply request all the resources at initial stage itself, right? If you are going to get the resources Ri and Rj at the initial stage itself, can we avoid here the deadlock problem or not? Yes, that will be the one solution. So that's the reason if you are going to disable the hold and wait, there might be a chance of avoiding the deadlock, so that we can prevent the deadlocks, right? And another one is there should not be any kind of preemption. Means if preemption is there, means I have allocated one resource to the process PI, and after certain time I have preempted this resource and given to process PJ, then PA has to wait for long time, that might lead to deadlock, right? That's the reason the solution for here is you have to take the resources what you want for the execution. So I can say it as take the resources away. And another thing is I can say the necessary condition circular wait, which means that generally if circular wait is there, process P1, P2, P3 having R1, R2 and R3, P1 is requesting for R2, P2 is requesting for R3 and P3 is requesting for R1. As you are going to have circular wait, means loop, definitely it is going to have deadlock occurring. Now how we are going to prevent it? We can prevent it by using order the resources in increasing order. What is the meaning of it? Is when P1, P2, P3 initially are using R1, R2 and R3 resources. If P1 wants a resource of R2, they can request it. If P2 wants to have a resource of R3, they can request it. But if P2 wants to get a request of resource which are below the ID of the same process, like it cannot able to request the resource R1 because R1 is below ID of the R2. That's why it cannot able to request. Can it request further? Yes. Similarly, can P3 request for R1? No, because this is lower than the R3. So as we have to request the orders in the increasing order only, it can avoid it. So when it will get the chance, after completing of this process, it will come up with one more ID called R4, then it can request for this. So that's the reason if you follow this approach, definitely we can prevent the looping also, so that we can say it comes under deadlock prevention, right? So the thing what we are discussing here is how we can able to prevent the deadlock by simply disabling all these conditions. Means we have to come up with some new approach. What is the new approach? In mutual exclusion, it has to satisfy compulsory. It has to take all the resources at the initial stage itself, and it has to take the resources away once it got the chance to execute, and the order of the request of the resource should be in the increasing order, so that we can eradicate the deadlock in deadlock prevention manner. Right? So next one, deadlock ignorance. Right? the simple. The name itself having the clear meaning. We are going to simply ignore the deadlock. Ignore deadlock means when a deadlock happens in our system, we'll simply ignore it. The reason is it is going to like existed once in a while, guys, right? So deadlock existed once in a while means after a years or in a year one time will occur like that, right? Once in a year or once in a lifetime it occur. That's why the developers of the operating systems has ignored, especially like Windows operating system developers, Linux, all these people have just ignored deadlocks. So what is the solution for this one? The solution is simply restart the system, right? It's a kind of an example for an algorithm called ostrich algorithm, guys. Ostrich algorithm. Ostrich algorithm, what it will say, na? So there is a bird called ostrich. What it will do when any kind of tsunami happens, it will just simply dig a hole and it will put his head in the hole. By thinking that once I covered my head, the entire tsunami is not approaching me. It will think like that. But is it really happening? No. Right? So we are just, so the bird here is simply ignoring the entire tsunami and it will put his head into the hole. That's it. That is what we are doing also here. Deadlock ignorance. That algorithm we call it as ostrich algorithm. Coming to deadlock detection, we are going to detect the deadlock. Once we detect the deadlock and we can able to recover it, we'll see that in the next video. And coming to deadlock avoidance, here we are trying to avoid the making of deadlock, right? Means we are going to check for whether system is in safe state or not. If system is in safe state, then we will move further. If system is in unsafe state, we'll just simply we should simply not allocating the resources, right? So the difference between here deadlock prevention and deadlock avoidance is, in deadlock prevention, when two friends are fighting each other, we will have certain kind of conditions so that the prevention can be done here. In deadlock avoidance, when two persons are trying to fight each other, one person will run away from the place, then I can able to avoid the fighting, right? That kind of thing we can comes under deadlock avoidance. Okay, anyhow, in the next video I will take the deadlock avoidance and deadlock detection in more depth about it along with the problems, so that you can get a clear idea. Hope you understood this video clearly.